Hello everyone. In today's video, I'm going to explain you about the pointers in C. How pointers are helpful in C programming. Pointer is one of the powerful programming in C. So in pointers, always point to the memory address location of a variable. So where these pointers are used is the pointers are used in dynamic memory location, uh, and it is used in linked list, data structures, stacks, queues. For all these applications we are using pointers. So at the end of this video you will know how to declare a pointer, how to initialize a pointer. You can able to write a program using pointers and assigning pointers to variables. So all these things will be dealt in today's video. So what is a pointer? A pointers are a special variable. So these variables in which so for example, if you are using a pointer, so what is a pointer means? It is like pointing to some memory location. So if this is a variable, so if we declare int a equal to 10, so this is the value 10 which is stored in some memory location. So pointer will point to some address. So this address is some value. So this is the address and this is the value. So in this address location only this value is stored. Okay. So for how we are going to program this using pointers only dealt in this video. So the pointers always contain the address. The pointers are derived data type and it is mainly used for dynamic memory allocation. So in this case, integer a equal to 10 and float space asterisk b and b equal to ampersand a. So in this case, the b value will hold the address of this memory location so that the b value is equal to some memory location value. So in this case, this is a small code showing how the pointer variables are used. So in this case, integer a is assigned, integer uh, a is assigned to some value that is 10, and here in this printf statement the value of a equal to percentage d. So the value of a is 10. So the next step is the address of A is percentage P. So that is ampersand of A. So ampersand of A means the address of A. So the first value, the 10, that is the value of A and whose address is given by 0x7 0 FC2 1 C3 4. So this is the address of the value A. This gives the address of A. So the value of A is 10. So the output of this program is the value of A is 10 and address of A is this value. So here percentage P we are using in this program is used for that pointer values. So how to declare a pointer? So how to declare a pointer is, so it is how we can declare is using this data type asterisk pointer underscore name or data type asterisk pointer underscore name. So these are the three ways you can write. So data type space asterisk pointer underscore name or data type asterisk pointer underscore name or data type space asterisk space pointer. So the data type of the pointer and the variable to which the pointer variable is pointing must be the same. So the syntax, how you use a syntax for assigning a pointer is here in this case int a equal to 10 and int asterisk p. So int a equal to 10 means a value is assigned as 10 and asterisk p is is the pointer variable. So normally we use an asterisk symbol for pointer to access the variable a. So the value of asterisk p will be 10. So how to initialize a pointer variable? So int a equal to 10. So int a equal to 10 means this a value is assigned to 10 and whose address is 2000. So int asterisk p means pointer will point to the variable a. So what is the value of p? P is a pointer variable whose address is 4000. And if you want to if you want to access the address of this variable, we are using the syntax that is p equal to ampersand a. So where ampersand a indicates the address of that variable a. So this ampersand operator is called as address operator. So how to declare and initialize a pointer variable in the same line? So int a equal to 10, asterisk p equal to ampersand a. So asterisk p equal to ampersand a means the address is pointed, that is the value of a is ampersand a is the address of that value a. So another way of declaring is int asterisk p equal to ampersand a, comma a equal to 10. So this is a wrong method of assigning. So we have to initialize the value a and then we have to give the address. It is not simply giving the address and then we have to initialize. This is the wrong way of assigning pointers. So next is from the previous two slides, we can able to understand our ampersand operator is used to find the address of the variable and asterisk operator is used to access the value of the variable. This is a small code showing this and int a equal to 10, int asterisk p, p equal to ampersand e. So what are the two printf statements given is printf, we have in this first printf p and the second is asterisk p. So you can see in this code snippet p is equal to ampersand a. So which means that in the first line the address will be printed, in the second line the value of a will be printed. So the output is so next, in this slide, we can able to understand what is the use of asterisk and uh, asterisk operator and ampersand operator. Ampersand gives address and asterisk is an indirection operator. So in this case, a small program is given where the value of a equal to 10 and b equal to 10 and int asterisk p and asterisk q. So p equal to ampersand a. So ampersand a is p is pointed to the address of a. So whose value is 10 and q is pointed to address of b whose value is 9. So in this case printf statement, so percentage u is given. Percentage u stands for unsigned integer. In that first the value that is address of a has to be printed. So ampersand a means the address of a and printf ampersand b means address of b. Printf p. So what is p? P stands for ampersand a. So the address of a will be printed. Printf q. Q is ampersand b. The address of b will be printed. The next is printf asterisk p. Asterisk p is pointed to a. So what is asterisk p is p value will be equal to 10 and asterisk q value will be equal to 9. So this will give the address. So you can see the address is this one. So the address points to 49920. The second one is, it is the address of Q. The address of Q is 429838684. The address of Q. So the next is P value is pointed to ampersand A. So again it is 42998388680. This is address of P. And again the address of Q is this value 429983684, and asterisk P points to the value A and asterisk Q points to the value B as in the code. So this is a small example showing how you have to uh, use the address ampersand and asterisk indirection operator and address of operator in pointers. So one more example we can able to see here is the value of A is equal to 10, B equal to 10. Again P asterisk Q. Here P is assigned to both A and B. So ampersand A and ampersand B. So first ampersand A is address of A and ampersand B is address of B. P value is the address of A. So the previously P is pointed to B, so that here we'll get address of B. So let us see the output for this is, here precedence, the symbol is higher than the comma operator. In this case, address of A is assigned to P and ampersand B will be discarded. So A value is 10, B value is 10. A whose address is 429983680, B whose address is 42998983860, So if you see the output, the first one for ampersand A 429983680, that is your address of A, and address of B is 429983684, that is the address pointed to B, and P is previous values. So this is a next example showing the address of an indirection operator example. Here brackets are used for higher precedence and assignment operator. The first operand will be evaluated and the next one will be discarded. So in this we are using address bracket symbol here. So if you see the value of A is 10 and whose address is 429983680, and the value of B is 9 and whose address is 42998388684. So the output of this program, if you see, the value of A is the address pointed to A, value of B is the address pointed to B, and P is the address pointed to B, and Q is some value, that is 5064, that is pointed by Q, and asterisk P is now points to the value of B, that is 9. So one more example showing address operator and indirection operator. So initially the address A is assigned to P. The address A is assigned to P. In turn, the address of B is assigned to the pointer variable P. This is a small example showing where the memory address and the values are stored. If you see the output here, printf as ampersand A will give the address of A, ampersand B will give the address of B, and P here will, so the second one will be executed when compared to the first. So that is why the P value points to the address of B and Q value is Q value memory location will hold some address. So that address is 5064 and asterisk P will hold the address of B. So one more example showing the address and indirection operator reference. So in this case, P equal to ampersand A and Q equal to ampersand B. So in this, ampersand A will hold the value of A, that is the memory location pointed by A, and B will point the memory location pointed by B, and again this statement printf percentage U P. P will hold the address of A itself and Q will hold the address of B. So in this case, printf asterisk P. So asterisk P means asterisk P points to the value A. So in this case, we are using how internally the pointers are used in storing the values in the memory location. So next is indirection operator. These are some ways to declare the pointers. So what is the output is, so here the value of A is equal to 10 and B equal to 9 and integer C is also declared. So int asterisk P and asterisk Q, here P equal to ampersand A will hold the address of A. So this is address of A and Q will hold the address of B and C equal to asterisk P will hold the value of A. And in this printf statement, the value of A is 10 and the value of asterisk P is also 10 and printf C also holds a value of A, so the value is 10. So previously we have used only a single pointer. So the next concept is pointer to pointer. So this is multiple form indirection or this is also called as chain pointers. So normally a pointer contains address of the variable. When we define a pointer to pointer, first the pointer contains address and the second pointer which points to the location. So this is a small example showing the pointer to pointer. So the value the is assigned. This is the first pointer and this is the second pointer. This is the second pointer. So second level pointer. So this concept is called as pointer to pointer. So example for pointer to pointer declaration. So in this case we are using double asterisks. For pointer to pointer variable declaration, we are using double asterisks. This is a small code showing how the pointer to pointer is declared. Int asterisk P, int asterisk Q, P equal to ampersand A, Q equal to ampersand P. So this is how we are accessing for a double pointer. This is a small example showing the usage of double pointer. So in any of the formats, you can use this method. So A equal to 10, B equal to 10. Here asterisk P, P is pointed to A. So here we are using a double pointer. Let us see what is output. So printf asterisk Q. So asterisk Q means it is a double pointer, but it points to the value of A. Asterisk P also will point the value of A. Asterisk Q the first notation will hold the address of P. That is the first pointer, and P also will store the address, and A value is 10. This is the use of pointer to pointer in C. So now one more example showing pointer to pointer. So in this, where the value of A is 10, B is 9, asterisk P is a pointer which is pointed to A, and double asterisk also pointed to A. This will give the address of A, and this is address of P. So asterisk P will give the value, that is the value of A is 10, asterisk P also 10, asterisk Q is the address, and P is also the address. A value is 10, asterisk QQ is equal to 78. So this is the output, and this is one of the best example for how you have to declare a pointer to pointer in C. So apart from that, we can use void pointers also. So void pointers can be used using the syntax void asterisk pointer underscore name. So void asterisk pointer. So there are different types of declaration, like integer declarations are there. So for example, if we want to declare in pointer as an integer, means we can use the return type as int, and cannot point to the, and this pointer cannot point to the float variable or some other type of variable. So it can point to only one type of variable. So to overcome this problem, we can use the void pointer. A pointer to void means a generic pointer that can point to any data type. So we can assign the address of any data type to the void pointer. So if it is only integer, means we can use the integer data type. So this is a use of void pointer. So this is a one best example for void pointer. So integer I equal to 9 int asterisk p. Here float asterisk fp. It is a declaration for the return type as float. And void pointer does not return any variable. So the void pointers, the null pointers can be defined in two ways. So what is a null pointer is, it does not have a point to any memory location and hence does not hold the address of any variable. So this is called as null pointer. To initialize a pointer variable when that pointer variable isn't assigned any valid memory address, means that pointer is called as null pointer. So how we can declare a pointer using arrays is, so here we have declared an array with three values 1, 2 and 3. This can be pointed to using a pointer. This is a way you have to use a pointer to initialize, to declare an array. So in order to read all the values of an array, we are using the for statement. And this asterisk p will point to all the values present in an array, that is 1, 2 and 3. So one value will be read and displayed. So I hope that everyone can able to understand the pointer concept, different ways of understanding and writing a program. This video will be hopeful for you to write powerful programs of pointers in C. Thank you.